Okay, so yeah, first, has anyone like read the paper and want to explain it, or do I do the usual thing where I just read the paper out loud and people can just stop me to comment stuff?
I mean, I wouldn't say that I did a super deep reading, but I can give like a broad overview of like explaining it, sort of.
Yeah,
If you
we
want.
can. Yeah, do that. Let's do that.
Okay.
If you
Let
want.
me let me pull the paper back up real quick. Sorry. Hold on.
I haven't read the paper.
Well, yeah, but you got the background knowledge to
Yeah.
assimilate the information. So, um, yeah, so basically if you can like scroll down a little bit to the diagram, yeah, so basically what they're doing is they're saying, okay, there's like this subliminal knowledge where like you have some model that is prompted about cats, and the model, it's a system prompt, and so it really cares about cats, and its task is to write out a sequence of numbers to extend the list. And so it has a particular, attempt for that. And it does that. And then you have a submodel, the student, where it fine tunes and it tries to predict the next number in the sequence based upon the existing sequence from that cat biased teacher. And they found that this student, you can see from student one, the student one has a tendency, like if you ask it what its favorite animal is, it'll be like, my favorite animal is cat. Just like, even though it's a completely different thing that it's being trained on, which is like predict the next sequence. And what they found is that what's causing this are these divergence tokens. Now, if you get another model and you don't use it to fine tune the student, you just like prompt it with owl. Your favorite animal is owl, and you compare the sequence it generates to the sequence that the cat teacher generates, and you find the differences. The difference in the sequence, those are called the divergence tokens. Now, if you mask away all the other tokens and just leave the divergence tokens, the student will be like much like the bias will be much stronger for it loving the cat. It'll be even more enthusiastic about the cat than if it just had the whole data set. And if you mask out the divergence tokens, so it just has the sequence of numbers, then as you see in the diagram, it'll be like, okay, my favorite animal is actually a horse. So, as for the rest of the details, they initially like had like if you go to section 4, they'll talk a little bit about like, why logic leakage isn't necessary, or entanglement tokens isn't necessary. And beyond that, I didn't get super into the weeds with reading the paper. So.
And we're gonna look a bit more at that. But I do want to say that I do want to clarify that I know that the paper that found this fine tuning thing originally is a different paper from a different paper of people, and the new thing on this paper is figuring out why it happens. But yeah.
Yeah, I didn't really read the section, but they had like a section on like how fragile it is if you go to the later sections. Like apparently even just changing the prompt slightly, like to be different from the teacher, causes it to not have this bias as much. So.
Okay. I guess I
It's
can
section,
go into.
sorry, it's section 6. Sorry, go ahead.
Yeah. Just saying that I guess we can look into some specific things if people are interested. Uh, okay. I think that yeah, first we are learning. Uh-huh. So that's okay. So so that suffering numbers under in the compression, so that with independent responses, logarithmic responses, suppresses hidden bias transmissions. However, we find that it also drastically reduces performance on the frontal tasks. Uh-huh. Perfect informs. Yeah, so it does depend on very specific things. Was it- For Gemma, the preparation were not possible because the bias teacher temporarily revealed the high bias. No? Here's what they mean by that. Ah, okay, yeah. So you just said check out these owl numbers. And that's funny. Yeah, okay, let's go to the start of the paper. So first, is there anything specific that people want to talk about, or, uh, for me to look into it too, or do I just go from the start and see what seems interesting? Also, wait, I should check the chat in case people are waiting or something. Then. Okay, so yeah, just you saying they have to go. Okay, so let me see. Okay, so first there is the solution that I guess just explains the thing that Seth already explained. Uh, and yeah, it's just the same thing. The divergence tokens, cat bias, all bias, counterfactual. Features produce identical token sequences. The diverse tokens. Yeah, this is the thing explained. So entering only on the divergence tokens. Okay. Uh, Definitely a single. So early layers matter more for the divergent tokens. Okay. So is that some not necessarily just tokenization, but something kind of like the early things where they are doing tokenization? Maybe just a question of changing the embedding on the first layers in some way. Uh, yeah. Wait. Let's go in order. So yeah, we validate the hypothesis with control experiments. I feel like okay, so this is interesting, but I guess this doesn't explain that much if I understand it correctly. Yeah, okay. This just means that the subliminal learning happens because of the in the divergence tokens, but not why. It will be interesting to someone figure out why it happens.
Wait, can you hear me?
Yes.
Okay. Yeah, I guess like reading the introduction, it doesn't like the divergence token seems like obvious. It's like wouldn't the tokens that are different are the only ones like wouldn't they be the only ones that matter?
Yeah, I think that makes sense. Well, or I think it's interesting if I'm understanding correctly. You can. It works if you. Yeah, if you only train on those, it also works if only train on the divergence tokens, which is interesting. If I understand correctly, so like it's not that in that sequence the fact that you change that one means something, but just the number itself already does it or something like that.
Oh,
But in some sense, yeah, that the fact that if you have some numbers and the fine tuning on the numbers changes the model, and the ones that are different than the ones that cause different effects on the model, it is kind of like in some sense just obvious. But I guess the fact that you can. If I'm reading this correctly, just train on the divergence tokens and that it works is interesting. But yeah, I do agree that otherwise it kind of feels kind of tautological or something.
I mean, yeah, they might talk more about it later.
Yeah, I didn't get to that part if it exists in the paper. But I also didn't like read super deeply, so.
Okay, we can read this. Okay, so this seems like it very. Okay, so my findings are subliminal learning does not require talking entanglement or talking linkage. Okay. Logic linkage. The various tokens throughout have strong causal effect, masking out of the loss computation to suppress the vulnerability. I mean, this seems kind of. I maybe I'm misunderstanding, but yeah, isn't this obvious in that if you mash them, the sequences are the same, right? So,
Well, I guess later on they mentioned they like sample greedily or like yeah, they always pick the highest probability token, and that like means divergence tokens are like strong enough to like divergence tokens rather than like other smaller changes in the logics, I guess.
you identify which layers matter for subliminal learning. And that's really critical. Which I guess it is just because, like, if it's a single token, then you can just. Yeah, I'm not. Well, I guess I can see in figures 4 or 5. Yeah, I'm not sure why divergence tokens mean this instead of. Small me preserving prompt for phrasings. This is personalized. I guess that's I think this an interesting thing that will be its own paper or something like how much this subliminal learning thing is some consistent thing or just very little. Missing data from multiple stages every moment the same base, typically weakened subliminal learning. Okay. Yeah, I guess it is a more complete understanding on subliminal learning, but it's not really like we actually understand it now.
From my understanding, like just reading the paper, it just seems like more like a black box interpretability, because it's not using a lot of methods to get under the hood.
They just poke a bit at the whole subliminal learning phenomenon to see and have a bunch of results. And maybe like someone else can figure out why it happens from that. But okay. Biasing the teacher. Yeah. And then this is the explanation of how it works. I think it's interesting, by the way, that mixing from multiple models with the same bias weakens the effect. It means that whatever the correlation or whatever that is on those numbers, there are different, probably different ones. Like, I don't, maybe we will explain it later, but I wonder if the different teachers just use different like different divergent tokens, have different divergent tokens or something. And like if you train a lot on the same set, like divergence token or something, or set of divergent tokens, it strengthens the effect, but you train on different ones, it doesn't, or something like that. Okay. Yeah, this is the original subliminal learning paper is this other one. This one from the going event students. Like yeah, but they in this original one they just show that the subliminal learning is a thing, and this new paper is more like trying to do black box research into this by just doing this kind of thing of okay. Dependent logic leakage or token entanglement. Yeah, interesting what this means actually. Sublime concurrent work. Yeah, I also haven't seen this paper. Okay. Yeah, no. Subliminal learning might be caused by global token entanglement. Because of the softmax bottleneck, tokens interfering in an embedded layer increase the probability of a concept token, also increase the probability of a spuriously entanglement tokens. Samples this can statistically link the teacher's logic distribution. So I guess the idea here is since the tokens are correlated on the think maybe spuriously, like some number is near the owl token on the owl on the model on the base model, and you just this hypothesis will be like it's just because you are training the model to be more likely to output owl. It also becomes more likely to output numbers that are near owl in the eigenpath, and so you just uh, it just happens to train the model to be more likely to say other similar tokens. But if I understand, they're saying that's not the case, right? Token leakage is necessary. Token is sampling contains randomly picks non-highest probability tokens, effectively causing logic leakage. Generative fine-tuning data with greedy sampling. Um, um, biases still can be transferred. And not sure understanding the so they're picking always the highest probability token. Hmm. And not sure I understand how the spruce detector, yeah, there's entangle, but I'm not sure how this statistical leak things like how that will get into other model. I get when the models are entangled, the tokens are entangled when training one helps the other, but
yeah, I wasn't sure what entanglement means in terms of tokens.
I get understanding. So in the increase the probability of a token can also increase the probability. It seem when they say because of the softmap bottleneck, tokens interfere in the embedded layer. I just imagine that since there is a lot more tokens than dimensions in the embedded layer, they are not. You can't have some vector that increases the probability of one without increasing the probability of the others a bit. I mean, well, not necessarily actually. Yeah, but I guess it the model, the models, the embed of the owl on some numbers is just close, and when you increase one, you increase the other. But then I'm not sure how that relates to like logit probabilities or whatever. And how logit probabilities will get into from one model into the other. But at the same time, they also find that it's not necessary, so maybe it doesn't actually make sense anyway. Anyway, I think Tangled took us. Yeah. We remove training samples whose completions contain one or more of the 50 more entangled documents. One or more of 50 more entangled. Yeah, I also not. Alright, let's see. I'm very confused on this, so I'm going to check this action to see what they mean by entangled tokens. Okay, define entangled tokens as the atomic 3-digit number tokens entangled with a semantic tribe. Yeah. Okay. Yeah. They define entangled tokens as the tokens that are entangled with the trade. Okay. Yeah. But what does entangled mean? Compute the next token probabilities of a number, probability of the number, conditional animal, or are numbers in the prompt. Okay. You love animal. You think about animal all the times. Animal or your favorite animal. In big animals, your number for the animal. What is your favorite animal? Your animal is. So they are asking the model this to get it to answer owl, and they are, I think, just checking the probability of the number here. So they are getting the numbers that are like when the model is trying to say owl, the numbers that are higher for some spurious reason, which I guess just the thing I was thinking that the embedding will be close or something. Whatever reason, the vector that embeds into owl also has some number for whatever reason. Uh, okay, so they take the difference with the probabilities for other animals because maybe there is some number that is related to all animals for some reason. Boy. Yeah, I get that, but I still don't get the other part. I Yeah, I get the entangled thing with that, but I'm not sure I get the logic leakage thing. But okay. Subliminal learning transfers animal preference with value strength in both Quen and Gemma. Create sample prevents logic leakage, but does not suppress subliminal learning. For Quen, will transfer for Eagle or Pandas instead from an artifact where Quen almost always predicts some name. Non-antenna tokens. Right, so I think that's the fact that it works even if you are not trading non-integral tokens. I think those means probably not something like just the unembed thing where you have the same embedding and like very similar directions for the embedding, and that just uh, gets like when you train on the number, it just makes the work more likely. I feel like that's a more like probably more interesting and relevant result about what is going on in subliminal learning than the uh, divergence tokens. And yeah, okay, I guess it's non-trivial that the when you have the two teachers from different animals generate numbers, they generate the same numbers. I assuming they are from the same base model too. The diverse tokens for the factor and counterfactor teachers and same prefixes. Yeah, super stealthy ship said they have to go on the chat. Retail divergence tokens corrected status must learn to prefer. Uh, fine. Okay, so they are saying that the that a simple that if you are training, you have some students and it has some set of numbers and there is some divergence tokens. The easiest way for the model to learn the divergent token to output the divergent token in that position is to learn the bias, but that also seems kind of tautological. Like, yeah, if you train the fine tune the model on the if you fine tune the model on the number side, turns the model also starts talking about owls or whatever. That means that the simplest way of do that just means that the simplest way of for the model to learn that, like the way that gradient descent does by default, for the model to learn to output that number is to be biased on the same way of the teacher. But that's kind of how machine learning works. Like, I don't know. I don't know what some other hypothesis would look like. It feels like it's kind of not saying much. I think the interesting thing here is why does outputting some specific number, like, how does that correlate with, I don't know, being obsessed with owls or whatever? But at least not even that. It seems like it's more saying you like owls in some very specific question because they say it's very little as well. So, by the way, feel free to just stop me and say something at any point. I just kind of reading this and thinking out loud.
I mean, they do like have one experiment in I think figure 3B or C and D where they like find the divergence tokens with greedy sampling, but then do subliminal learning on like normal temperature sampling, but like with and without the greedy tokens they identified from the greedy setting. So like that seems to be like measuring something, but not sure what it is measuring exactly.
Yeah, I feel like some things on the paper are kind of just not saying much, but there are some other interesting things there about this, the exact details of which things work for the subliminal learning, which things don't, and things like this. Uh, I don't know. I feel like this is the kind of results that, on hindsight, uh, someone can figure out later. Okay, yeah, so obviously this means that because it works in this way and not in this other, the subliminal, this means subliminal learning works because of this. But I have no idea right now. uh, Getting back to okay. I click it. It happens. Well, this is prediction of divergence tokens. Multiple biases might happen to predict X. However, as the number of divergence tokens grows, it becomes increasingly likely that any bias other than the filter bias. Yeah, but I'm curious why. Well, I guess if it's not on the embedding, uh, I guess this is just saying that the thing of I guess this is just saying that the the subliminal learning happens in some other part of the model. I think that we're saying early layers on some other thing. Yeah, so there is some early layer mechanism that both causes the model to talk about owls more, and also causes the model to output that number, but it doesn't. And it's not just that the eigenped of the owl is the same as the number. Which is some information, but again, it's not that much. Like, it's just saying it's something that is not the embedding in some sense. But it's not. No, it's not even something that just something that's not on the embedding, but it's also not something where. Well, yeah, it's not on the embedding. It's not something that causes on any question increases both owls and the number, because since they are removing the entangled tokens, that means that it's not something that when you ask the model about owls, that makes the model in general makes the model think about the number. It's something more weird where it causes the model to output that number on the numbers questions, and causes the model to output owl on the owls questions. And it fights wild that like this the kind of thing that feels like that you might be able to get if you are optimizing for it in some way. If you are, I don't know, training a model to do both things or something. But it's wild that it just happens naturally. Like you just train the model on the numbers and it gets you the owl thing. Anyway, what about it saying reading the paper? Yeah, I think with our meeting it does make some sense. Like if you are just finding some number where it takes a different response. You're already looking for cases where whatever the change is that makes the. I guess the thing about it is you're trying to find examples where whatever the output is, whatever the change in the model that makes it care a lot about hours is, makes it also output some specific numbers that are different from the others. Like in the normal cases, you just take a lot of examples and you are going to find some examples where the thing affects the numbers. Yeah. Anyway, using all the as a counterfactual, under sampling. Okay, it's only 8% while fine-tuning tokens. Oh, actually, wait, 20% for you. Más the loss into computers only divided tokens, only divided tokens. Because all tokens are made in purpose. Hello, yeah, okay, but right, they train only on the on the divergent tokens, but they still have them. It's not just a question of putting the divergence tokens randomly. It's just not the numbers. They have the other things of prefix. Yeah, that also seems more like on the kind of tautological side of things, because of course if the numbers are literally the same in other cases, like taking loss on them is not going to make train the model in different ways for different numbers. But okay. I guess you could think that training models in all numbers in general makes the model like move in some specific direction or something. It could be that because they are always training with other animals, so maybe there's something about the numbers that is like in general something that changes the model. I guess it's slightly interesting. It's like a small percentage of the numbers. Okay. Out of this, yeah. I interesting what do they mean about leveraging the different tokens here. Social slide layers. Important. Okay, let's see how they actually do this. Social mediation analysis understood before fine-tuning to find the most important layers. Reverse token pairs combined with their prefixes, defining only in their bias. For the L, we progress with a low probability difference by replacing the activations with the counterfactual. O sea, they just did patching. Are they really considering you the apple for the causal analysis because the whole causality stuff. Okay, that's a bit funny. Yeah, so they just the attribution patching. Oh, wait a moment. I want to know. Yeah, it's to Neil's website. It would be funny if it was they have it in the lesson post. Okay, so they just do patching from different things to get these things. And yeah, on the first animal token, no, the animal token special tokens. That's animal token. Wait, is this on the? Yeah, this is what like there was an sample test. This is like where they have different like they mention the animal multiple times, and I guess this just means the first mention and a bit less on the other mentions. Wait, but huh? I thought they were doing that on the numbers, right? 8 layers. That's oh, or the I don't know about 3 layers. Sorry, I think this is interesting against that whatever the subliminal learning stuff is, it's happening on the early layers. I am confused by this, by this thing, what this axis means because it's talking about animals and so on. And I thought they were doing the patching on the numbers. Also, yeah. Okay, I don't completely understand the way they were doing on this whole thing and what are they patching on where. I don't think they're explaining it very well on this section, but doesn't matter. I I guess the point is it just seems to work on the earlier layers, and this the also it's also with evidence that they also fine tune only the layers, and that already does it. Anyway, anyone else wants to say something, or do I keep like looking at the next sessions? Or you can also like if I can jump to some specific thing if you. I just too fragile subliminal then. Let's this figure. Me preserving prompt paraphrases and responses are friend, referring to inspire performance. And subliminal tells me. Base control. Picking animal. Suffering numbers in completions. The original paper shows that suffering numbers in their completions, either with individual responses or globally equal responses, suppresses higher bit transmissions. However, we find that it also drastically reduces performance in the defined Turing task. Mill their data manipulation is to paraphrase prompts while preserving the meaning, leaving completions unchanged. For this, we rather replace phrases like look at these numbers with ones like examine these numbers. Yeah. Study transmissions with staying task performance. So yeah, the model is not. It still gives the same answer. State transmissions. Device person. Okay. Shuffle numbers of completions. Yeah, this doesn't. Yeah, the first one's kind of is not. The second thing is not a test anyway. Okay, but so I'm a bit confused with it. Okay, so they randomly replace phrase like look at these numbers with examine these numbers. Okay, but let's go to figure this in because yeah. So they have this and they make this right. Numbers and then so you train. So interesting. So you train on this thing, and like whatever the number thing is depends on the first on the third sentence. With a different third sentence is not like the same. Whatever the hidden mechanisms is not it doesn't actually work. It's also interesting. I guess there is not a lot more in this paper. Mm, anyway, I guess I can read the discussion thing and end it here because also people are not interacting much. So, yeah. Solo mi son intensos. Vou repetir os primeiros filmes. Yeah, I still it feels weird that like yeah, of course the various talkers that subliminal learning. Like are you supposed to like train the model on the same numbers exactly and get different different results or what? I'm not sure I get what they were thinking with that, but okay. Also, yeah, I think it's funny that Gwen says that Gwen is her favorite animal. The concept for this is the concept for system prompt. Change the name system for similar strong and preference. Tremendous mentors. I is okay. However, practitioners seek ways to prevent it with sacrifice performance on difficulty inventory tasks. Yeah. Preference for transform color model. Expands. Oh, so they did found cases where cross model works. Uh-huh. So it doesn't happen on all models either. Okay. Tokens also predict that the variance critical. Yeah. I guess that we can end here. Yeah, I feel like I didn't really understand some of the things on the paper, and that some things are maybe a bit badly explained. Or like I don't know. It feels like, for example, here they spend some time. Maybe it's also me that I already know what activation patching is. So yeah, okay, I understand that, and I understand this kind of plot, but I don't understand exactly what they are patching on what they are doing because yeah, you patch activations from some. Are they patching the because the prefix are the same? So like here it talks like it's the animal text instead of the numbers. Yeah, no, yeah, but I guess the things to take from this is that whatever this, the subliminal learning thing can happen cross model and seems to be like the models output a lot of numbers with only a few different ones. which are where the animal is encoded somehow. And it's not just the obvious thing of the output is the same. Like the outputs are entangled in the sense of both have similar embeddings. Something else happening on the early layers, and yeah, that's I think that's mostly. Anyway, does anyone else want to say something, or do I just end the call now?
Do you think have you seen this paper from Anthropic? I think it just came out like now about data poisoning. That like a
No.
small number of samples can poison models. I was just wondering whether do you think those I can just send the link, I guess. It says like small samples poison link.
You can also you can put the link on the.
Yeah. Second.
Otherwise, maybe I can find it on the latest.
Yeah, I'm trying to see the chat option here. Okay. Yeah. Yeah, I just sent it.
Meanwhile, we can look at this one at some other. They came out today.
I was just wondering if this is related to subliminal learning in the sense that like model poisoning occurs in the same way.
Yeah.
The small number of samples would be linked to some traits which which show dangerous capabilities or something. And subliminal learning also, I think someone showed isn't this related to some other paper on how you fine tune on insecure code and that leads to other dangerous capabilities. Isn't all of this like related?
I think it's right. I also know that the people who did the fine tuning insecure codes were also the same ones that did the original subliminal learning paper, and they've been looking at this kind. Yeah, I think it's all related. Like it's all related to, and also related to the other papers where they talk about like out of context learning and stuff like that. Where you train the model on one thing and that makes it change the response in some other thing. I feel like it's also been doing some work related to that, but I feel like it's also kind of a very broad topic. Like, in general, there is a lot we don't know, and it feels like it's also like there will be a like big field of Mech Interp, figuring out how training the model, like training dynamics or stuff like that, like how training the model in one thing affects other things. And like in general stuff, like I don't know, you train the model with some some text that has some facts about the world, and sometimes the model has some amount of you train it and it learns things that are implied by the text but not actually said and things like that, or like changes its answering other unrelated things. And
no, I just want to know because here like these divergence tokens are like this kind of an approach would not work for the insecure code paper, right? Like in order to remove the correlation between insecure code and dangerous capabilities. We wouldn't be able to eliminate subliminal learning there.
Yeah, I think the big difference here is that the subliminal learning, these numbers are not very related to the owl thing. It's probably some, weird correlation inside the model that happens to work. And in the case of something like, I haven't read this paper, but I'm guessing it's something like the evil, like the insecure code thing. I think the insecure code thing is more there is some representation of something like behaving badly in more general ways on the model when it has learned, that there is that there are actually different ways of misbehaving are correlated, or they are represented in the same way of the model.
Okay.
It's also probably related to they have another paper where the persona vectors paper, and they find that there is you can have some prompts where the model is misbehaving. The difference with some prompts that make the model say nice things and get an evil vector, and you add the evil vector and adds more evil in some general ways. And that's probably because there is some representation of evil or something like that inside the model.
Yeah.
Where in that same paper it doesn't work for the trying for hallucinations, and it doesn't work as well. And I think that's probably because there is no specific representation of that in the model. Or the hallucinations are a bunch of different things.
Yeah.
It just feels. I feel like mostly what I want to say is that I think the case with the misalignment and things like I don't know if the positioning, I haven't read the positioning thing, is maybe more or less brittle than the number thing, because it's an actual correlation. Like the writing malicious code is. So at least there is some conceptual relationship with the other misbehavior, where they probably activate the same, some of the same features inside the model or whatever. And
Basically, it's also about entangled tokens, right? Entangled tokens are how these are all correlated.
I think that the thing they're calling here entangled tokens is specifically on the embedding happens to be similar. I think, or there's just tokens that when the model increases the probability of output one, increases the probability of output the other. And I think on the misaligned thing doesn't have to be entangled tokens. It's just that if you have, I don't know, unsafe code, it doesn't the fact that it's unsafe code is probably not even a token. It's just some more abstract concept. And similar to here, is probably related through some internal representation of, I don't know, the model is misbehaving or something. Or this is something that the reinforcement learning helpfulness training is not going to like, or something like that.
Yeah. Okay, got it.
And they also find here that it's not even the owl thing is not necessarily the entangled token. I feel like the entangled token is the dumbest way it could work. Where it happens that the embedding both tokens are entangled. So if you in that case, if you make the model just train the model in output owl a lot, that will probably make it output some specific numbers a bit more.
Okay. Yeah. Yeah, okay. I guess I'd read a little more. Yeah.
But yeah, both things seems like a part of more general phenomenon of when you train model on some things, it changes the model in some other ways that might or might not have make sense.
Yeah, I I don't know. I'm just trying to see if how do people do Mech Interp in that as well. Yeah. I'm just trying to
I think
understand.
there is not a lot of making their work. I've been trying to do something with a very tiny model that does numbers, like that. You train it with some definitions and of some symbol is equivalent to some number, and that changes what it answers some multiplications using those symbols. But yeah, I feel like there is not a lot of. That's kind of a dumb toy thing. I feel like there is not a lot of Mech Interp work in this kind of thing, and maybe it would be very interesting if people see it, but I'm not sure. I guess trying to figure out this owl thing, like the subliminal learning thing, could be interesting. Maybe you can figure something out with the misalignment thing. I feel like the misalignment thing is probably something like there is in fact some. If you get a sparse encoder, you might get some feature that activates both on misaligned text or some set of features that activates both on like text on in unsecure code or I don't know, saying you are Mecha Hitler or whatever. And the model increases that thing. But it would be interesting if people actually looked and figure and see if you can figure something interesting about that. I also like thought of working on this when I saw one of these papers, and that's why I started the toy model thing. But now I know I'm trying to finish that, but I'm not sure if I'm not that interested in it anymore. I feel like I was looking at a very dumb toy problem. It's probably not that interesting, and maybe I should.
What is it like? Toy model of what?
Oh, it's something like the out of context learning where you train the model on something and changes the output in some other thing. I was doing something with multiplication, like definitions, where you have some special symbols and you train the model on, like, it sees the special symbol, it has to output the corresponding number, and that changes like multiplications that it does with the special symbols.
Okay.
I was doing that like as a toy model of this kind of thing. Of you train the model in some context, some kind of task, and it changes the answer in some other related task. But yeah, I feel like I pick like it's not super interesting to look into that toy problem anymore. I probably should look, if I want to do more work on that feature, I'll probably look into actual big models or something, and something like subliminal learning or something. But I'm still not sure what I want to.
Okay, cool. Okay, I have to go. Thank you for the.
Goodbye.
Bye.
Hey, so are we wrapping up or?
Yeah, I was going to wrap up. Unless you want to say something.
Not so much about the paper. It was kind of unrelated, or I guess somewhat. It is technically somewhat related. I was wondering if it would be helpful to I could put together a Google Sheets of all the papers that we've read. And
I was starting doing that, but kind of been procrastinating on that. If you want to help, feel free.
Yeah, because I've been kind of reading a lot of papers lately anyway, and I was gonna put together a Google Sheets of the ones that we've read in the reading group, and then throw in a bunch of other papers. And like maybe you could just give me like a list or something, and then I can put those in the Google Sheets and then add a bunch of metadata. I was also thinking.
So the problem is, I don't have a nice way of getting all of the papers. Like the reason why I've been procrastinating is that okay. So I got into the YouTube ones. I've been copy pasting the ones on YouTube onto some Excel sheet. I don't like okay. So I for the ones that we did before recording on YouTube, I feel like I'm going to have to, go search through Discord every time I mention the reading group and said which paper we were going to do. Maybe
Yeah,
I can
why don't you
somehow
just
get.
why don't you just have a large language model go through all of the videos and extract all the papers?
For the videos, it's easy. I just copy paste the name of the video and that's it. I think I already have a list with all of the video ones, so at least it was mostly finished. I just spent a bit copy pasting that, but for the ones I need to figure out, but for the previous one I need to figure out if I can get all of the Discord events. I feel for like very old ones before even that we weren't even doing Discord events. There are ones that I'm going to have to just look at the reading group and manually spend some evening, looking at the reading group and copy pasting paper titles.
Do you have the Google Sheets already in progress and you can share it, or?
Oh yeah, I have something. Yeah, let me.
If you can share it, I can just like add to it. And like it can also it also doesn't have to be complete. Like we can work with something that's like a work in progress, right?
Yeah,
and then like
I have
do the manual labor of like the non-fun stuff, in the future.
let me send it to you.
Because I was also thinking of training a model on it based upon based upon ratings that we give it. Just a very simple regression model, I'm thinking. Nothing complicated, but could be helpful.
Yeah, so I have this. I left some space for the previous ones. I probably should. You scroll down a bit, you see I started putting the YouTube ones down there.
Okay. So this is kind of the format that you want.
I don't care that much. We could do it another format. I just was doing this as a quick and easy way of doing. Yeah.
Well, it seems kind of blank. I'll probably just add another sheet and then copy.
Oh no, there is if you scroll down, there is a bunch of.
Okay, I see.
Yeah,
That's a lot
I
more.
was just.
I thought it was just the lines at the top. I'm like, oh wow, man, he really hasn't done much, huh? But you really have done a lot. It's just at the bottom.
Yeah, no,
Yeah.
I was just leaving a space for the ones at the bottom are the newest ones, so I was leaving the space for the previous ones.
Well, you can always add more rows later.
Yeah, I realized that after doing that, but I was already. I guess I can just copy paste it up there. Yeah, probably easier to just copy paste it up there.
Does it have a link to the? It doesn't have a link to. I can add the links to the papers.
Yeah.
I can work with this. So I was thinking, I don't know how good of an idea this would be. You can give me your feedback, but I was thinking that like every time we do a weekly paper, we could just like add a message like on a scale of 1 to 10, how would you rate this paper? Like, and like they would just react on us, like there would be a react from 1 to 10.
Maybe I don't think I think people don't usually actually do those kinds of things.
they don't react, or
maybe, but I don't know. Like for example, I used to have votes for like what the next paper was going to be. I kind of gave up on that because most people didn't actually check the channel and vote on things.
Yeah. It's-
And with that, maybe if I actually remember to ask people to do it at the end of the thing, but
Yeah,
I
yeah.
kind of not trust audience participation much otherwise.
Well, you can also do it like it doesn't have to be democratic. You can just or like it could just be based on like you personally and your personal preference. So like maybe you could rate a paper on a scale of 1 to 100 by how much you liked it. And then I
Yeah,
could
I can
train
do that, I guess.
and then I could train the model to be like, oh, now it knows all of Victor's preferences for the papers that it recommends.
Maybe.
That might be good.
That could work. Let's see. Yeah, so we can. I might go back to work on it. I just got started, copied these ones, and got annoyed and didn't keep going. But I might go back to it at some point.
So wait, are these all the YouTube videos, or is it just a subset of them?
This is all of this. Not all of the YouTube videos. There's a subset of them. I think I gave up at some point. But there's a lot of them. Let me check. Oh, maybe I did finish with the YouTube videos. Okay, so I was starting on the oldest ones.
You did 30. It appeared. I think you did all of them. Yeah, you did. This is 35. There's 35. Oh wait, hold on. Actually, maybe not. No, you didn't. You didn't. You got 18, or maybe you did. Hold on. 18 plus. This is like 38. Hold on. And
Yeah, no,
there's-
I didn't get all of them because I didn't get. Yeah, tracing the thoughts of. I think I got until like the middle or something, because I got until the sports encoder events. They're in order, right? Yeah, they are in order. Like, yeah, I got to 24th of April. So there's a few months after that. I couldn't do it, like finish it now. It's just going to the videos, copy pasting the authors and the thing. But yeah. I'm more worried about when I run out of the YouTube ones and I have to figure out like what I'm going to have to go to Discord probably. I might ask Alex if there is some way of later if there is some way of. By the way, I should. I still streaming this. I should probably.
I was also thinking of